Hello everyone. Welcome to my YouTube channel Trance. Today we are going to learn why the derivative of sine theta becomes cos theta. Everyone just casually states it without any proof. So today I'm going to resolve the mystery around it. So let's get started. As we know, sine theta can be traced back to a circle, and that too a very unique circle, which is unit circle, right? Consider this as a unit circle. Okay. Now, yeah, this correct. So let this be center. Now suppose we say we go to any random angle theta, right? And the radius is equal to 1. So now if this angle is theta, then we know that this height will be equal to sine theta, right? Okay. So what we'll do is let's move at an angle d theta, right? If this angle is d theta, then what is this length? This length will be approximately a straight line, and as it lies on a circle, because this theta is very small, it will be a straight line, and this is equals to r d theta, where r is equal to 1, right? So now we know that this length is equals to theta. So let's drop a perpendicular here. So this is the new length. Let me extend it a bit. Therefore, this length is equals to sine of theta plus d theta, right? And therefore, the increment, you can see that this increment value, what will this value be? Now consider this triangle. This is also right angle triangle. If this angle is equals to theta, right? And this angle is also equal to theta, right? Now this line is tangential to the radii, to the radius. So this angle will be complementary of theta, or rather you can say that this angle will turn out to be this angle phi. So therefore phi will be equals to theta. So this is 90 degree triangle, rather right angle triangle. So we have a right angle triangle there. We know that this is d theta, this is theta. The d theta is the length of this side. And what we require is this. As you can see, this is the base. This length is equals to cos theta d theta, right? And you can see that from this point it has increased to this much when you increase the angle by a small amount, right? So therefore what we can write is sine of theta plus d theta minus sine theta. The change is equals to cos of theta d theta, right? But you know that this is a very very small change, so you can write it as the small change in sine theta, and when you bring d theta that side, it will turn out to be the derivative of sine theta is equals to cos theta. Isn't it amazing? Can we do it for cos theta also? Yes, we can do it for cos theta also. Instead of this diagram, now you would drop perpendiculars from here this way, this and this, right? The triangle will be the same, right? Just now you need this term. So this angle, this side is sine theta d theta, right? But you can say that see that initial point was here and finally it moved to this point. So the change is negative. What is the value magnitude of the change? Sine theta d theta from here. So the actual derivative of cos theta is minus sine theta. We could have started with like the chain rule. People think that if I want to know the derivative of sine theta, it we can write it as maybe say derivative of 1 by root of 1 minus, or rather, let's keep it simple. Let's not go into tan and cot. 1 minus cos square theta. But here also you have to differentiate the cos theta, right? It is a vicious loop. You cannot solve it this way, or you cannot differentiate this trig identity sine square theta plus cos square theta equals to 1. You need to know the derivative of sine theta here and also cos theta here, right? Which is very, very like interlooped. And that is why people, when they shrug you off, now you know from where this derivation comes from. Why is the derivative of sine theta equals to cos theta? And why is the derivative of cos theta equals to minus sine theta? This is the actual proof which people don't show. This is the true mathematics behind it. I hope you enjoyed the video. Please like, share, and subscribe. Thank you for watching.